Good afternoon, everyone. So, I would like to start today's lesson just recapping a few things that we have done last lesson. So, in the last lesson, we have begun introducing calculus and we have started developing this concept of limits. So, when we are using limits, we're not actually getting to the value of our function, we're getting as close as possible, and we're we're not actually there, right? So if I had a function here, I want to get, for example, the tangent of this point. I could approach from this side, I could approach from this side, I could try and find this value, even though if it's not here, if it's like open, right? So anyway, so let's take a look at those problems here and let's work out the limits. You should be able to do all of those, but watch closely if you had any doubts. So first one, limit of h squared plus 5h over h when h approaches 2. So if you just put the values in, it would work. There's no division by 0 here. So I'll just show you two ways of doing this, because in this case you could just do h equals 2, so you would have 2 squared plus 5 times 2 over 2. So 2 squared is 4, 2 times 5, 10, over 2, so that's 14 by 2, 7. Now what if I wanted to simplify this first? So this would be the same thing as the limit, h approaches 2, and I can factorize on top by h. I can put h as my subject, right? I'm getting it outside, so h plus 5 over h. So now I can get rid of this. So it would be, oh, this is 2. So this is the limit of h plus 5 when h approaches 2. So that's 2 plus 5, which is 7. So you can see that you get the same result. You shouldn't get anything different, should you, really? Now, next one. So I've got a limit of c when x approaches 0, goes towards 0, and c is a constant. Well, how does that function look like? So what would f of x equals c look like? Well, it's a constant, right? If I have, let's say, x equals 0, the value will be c. X equals 1, the value will be c. X equals 2, the value will be c. So for any value of x, this function is c. So if I approach 0, the limit will approach c. If I approach 1, if this was 1, I would also approach c. My value would also be close to c. If I approached 2, I would also find c. If I approached last 2, so negative 2, I would also go towards c. So the limit here will be c. It doesn't matter which value we're approaching here, it would also be c. Now the last example here, if you compare with the first one, you wouldn't have two ways of doing it, because your h is approaching 0 now, and you've got a denominator here, so you cannot actually just substitute 0. You would have a division by 0. So in this case, you have no option but to simplify. So you can factorize. So here on top, we can factorize h, and then we get h squared minus 8. And down below, h as well. So we can cross those out, and you get h squared minus 8. Oh, sorry, limit. So limit when h goes towards 0 of h squared minus 8, which is negative 8. Now, if you plot this function, this point here would have to be blank, would not be filled in, because our function is actually not defined when h is equal to 0. Right? If this function is h to the power 3 minus 8h over h, this function can only be defined when h is different than 0. So this would not be filled in.